All right, so for our f of g of 3, first thing we want to do is find g of 3. Okay, so we know when x is equal to 3, g of 3 is equal to 2. So when x is equal to 3, g of 3 is equal to 2. Okay, so that means that f of g of 3 is just f of 2. Okay, and f of 2, when x is equal to 2, f of 2 is equal to 8. So that means f of g of 3 is equal to 8. All right, any questions on that one? Okay, and we do the same thing for g of f of 3. Okay, so g of f of 3, first thing you do is find f of 3. Okay, so we know that when x is equal to 3, f of 3 is 2. Clean that up a little bit. Okay, so now that we know that, so g of f of 3, that just becomes g of 2, since f of 3 is just equal to 2. So that means when x is equal to 2, yep, g of 2 is equal to 5. We'll bring that up a little bit. So that means your g of f of 3 is equal to 5. Okay. So again, just working from the inside out. All right, any questions on that one? All right, I'll leave that up for a few seconds. Right. Oh, anyone still writing? All right. Okay, so let's say if we wanted to find the domain of the composite function, say f of g of x, where f of x is equal to square root of x plus 2, and g of x is equal to the square root of 3 minus x. Okay. So that means if we have our f of g of x, then that's f of g of x. Okay. So we know that our g of x is square root of 3 minus x. So that's going to be f of square root of 3 minus x. Okay. So f of x is square root of x plus 2. And that means that this will be the square root. You replace every x with square root of 3 minus x plus 2. Okay. Now remember, for square roots, the radicand has to be greater than or equal to 0. So remember, you have the square root, the number underneath is your radicand. Okay. So here we already know that if this has to be greater than or equal to 0, then anything greater than or equal to 0 plus 2 would automatically be positive. So we don't have to worry about the outside square root. But this does have to be greater than or equal to 0. Okay, so we know that 3 minus x has to be greater than or equal to 0. Okay, so if we add x to both sides, 3 has to be greater than or equal to x, or you can switch them around and make that x has to be less than or equal to 3. Okay, so we know that if we go ahead and let's say, oh, f of g of x, I'm about to write f of x for some odd reason. We know that f of g of x has the domain of x is greater than or equal to 3. Okay? Which means that oh, where'd it go? Where'd it go? Nope, should be cannot equal. Oh, nope, I had it the right way the first time. Nope, I did it one way earlier and then I'm doing it a different way now, so. There we go. Oh, that should be less than. There we go. Yep, so it has to be greater than or equal to. There we go, that's where I messed up. This actually should have been less than since I switched them around. There we go. And I can clean that up a little bit more than that. There we go. Okay, so we know in here has to be greater than or equal to 0. Then we added x, and then we just switched it around. Okay, so if x is less than 3, we know if we have 0, and this is our 3. Uh-oh, that could have been a little further over, but get the idea. So that means everything here would make that true. So we know that your domain is from negative infinity all the way to 3 and includes it. So really it's like finding the domain of a regular function, but you have to do the composite first and then find the values that would make the composite actually defined. All right, any questions on that one? All right, I'll leave that up for a few more seconds.
Does the square root over a square root cancel each other out or something? What happens to that?
Oh, the square root over the square root? Well, this square root, because remember, this will automatically, oh, sorry about that, it's frozen. This will automatically be greater than or equal to 0. So since you have that plus 2, this will automatically be positive. So since this will always be either 2 or bigger, you don't have to worry about the domain of that one.
So I just work with 3 minus x?
Yep.
Okay.
Yep, because we just have to find out what values will make this actually defined. Remember, anything bigger than 3, and that's automatically going to be a complex number, because now you're dealing with negative square roots. Okay, any other questions on this one? All right. Okay, anyone still writing? Looks like everyone's done. Okay, so let's say, for example, if we wanted to find the domain of our composite function, this time where f of x is 1 over x minus 2, and our g of x equals square root of x plus 4. Okay. Now with this one, you're dealing with both a fraction and a square root. Okay, so you have to remember more than just the radicand rule. Okay, so you want to remember that the radicand, switch my A and D around. Must be greater than or equal to 0. That's for your square root. And your denominator can't equal 0. Okay, so for our radicand to be greater than or equal to 0, that means that for square root of x plus 4, that means that x plus 4 has to be greater than or equal to 0. So if you subtract 4 from both sides, x has to be greater than or equal to negative 4. Okay, so we have one stipulation of our domain. But we also know that for 1 over x minus 2, let me put the f of x in there. Actually, I'll put the f of x up here too. You don't have to do it, just to keep things a little bit clear. So g of x and f of x. Here we go. Now for the f of x equals 1 over x minus 2, we know that x minus 2 can equal 0. Or x can't equal 2. Okay, so we have both stipulations that we have to meet. And for me, I always draw out a number line just because it clears things up. Okay, so we know that 1, 2, negative 1, negative 2, negative 3, negative 4. We know that x can't equal 2. So automatically we know that's out the way. And we also know it has to be greater than or equal to negative 4. Okay, so if we start at negative 4, it can be equal to negative 4, so we go ahead and use our bracket. Which means it has to go all the way to the right, but it has to stop here. Because remember, x can equal 2. So it can fill that as an open circle and pick up on the other side. Now the thing about that is, that would be your first response usually when you see something like this. And the only reason I did it that way is because it points out that you just gave the domain of each function. You didn't give the domain of the composite. So that's where they differ. So remember, the first thing you want to do is you want to find the composite. And I'm going to show you where this domain and the composite domain will be a little bit different from each other. Okay, so this is the functions together. It's just from -4 to 2, and then it skips over and goes from 2 to infinity. Oh, that should be the u there. Yeah. Well, make a better looking u than that. So there we go. All right. Okay. Now this gives the domain of the functions, but it doesn't give the domain of the composite. Not the domain of the composite. Okay. Now to find the domain of the composite, of course you have to find the composite first. So f of g, remember that's just your f of g of x. Okay, so our f of x, or our g of x rather, is square root of x plus 4. So that's f of square root of x plus 4. Oops, sorry about that. Let me bring that up some. Okay, now f of square root of x plus 4, that's 1 over square root of x plus 4 minus 2. Okay. Okay. So now here we have the square root in the function kind of again. And some of it will be the same, and some of it will be a little bit different. Okay. So if you have there, we know that square root of x plus 4 minus 2 can equal 0. Okay. And we also know that square root of x plus 4 has to be greater than or equal to 0. So you see it's just a little bit different. Before, we had x couldn't equal 2. That was our denominator. But here, if you notice, once you get the composite, your denominator changed a little bit. So now this is your actual domain of the composite. Okay, so we're going to continue on the next page. But just wanted to point out, this is how we find the domain of the composite. Okay, so we'll continue on the next page. I'll leave that up there for a second. Uh-oh, let me bring that up some. Okay, and I did it that way because probably 95% of the problems people have with this one is the fact that they did it the first way. And whenever I say, okay, well, how'd you do it this way? And they always do it the first way, and that's where their problems come up. So this way, if you know, okay, if I do it that way, that would be wrong. So you want to do it the way on the bottom first, and then find your composite. Find your domain. Anyone still writing? All right. Okay, so we'll continue on the next page. And we left off with square root of x plus 4 minus 2 can't equal 0. And square root of x plus 4 has to be greater than or equal to 0. Okay. So now, for this one, if we add 2 to both sides, square root of x plus 4 can't equal 2. And we square both sides. So x plus 4 can't equal 2 squared. And actually, I can bring this down a little bit just to give me a little more room to work with. So x plus 4 can't equal 4. So if we subtract 4 from both sides, we know that x can't equal 0. Okay, so we see it changes it up just a little bit. Okay, so we also know that, where did I leave off? Square root of x plus 4 has to be greater than or equal to 0. Which means that if we square both sides, x plus 4 has to be greater than or equal to 0. Which means that x has to be greater than or equal to negative 4. Okay, so we have our two actual composition domain terms. Okay, so we have 0, 1, 2, negative 1, negative 2, negative 3, negative 4. Okay, so x has to be greater than or equal to negative 4. So that one didn't change. The one that changed is the value that it can equal. That's the 0. So we know that x can equal 0. So we'll leave that as an open circle. Okay, so we know it can go there. Again, x can equal 0, so it skips over and goes all the way to infinity. Okay, so the domain of the composite f of g of x is all the way from negative 4, and we're going to include it, but it stops at 0, then it picks up on the other side and goes all the way to infinity. Okay, so this is your actual domain. All right, so any questions on that one? All right, I'll leave that up. Bring that down a little bit. Leave that up for a few more seconds. Oh, no. Right. Put it over here. Oh, thank you. Oh, it's fine. Oh. There you go. All right. Oh, anyone still writing? All right. So we'll look at a few of the graphs you'll encounter on the homework. Okay. So this is the function g of x. They didn't tell you any values or what the function is, just that it's g of x. They want you to find g of 3 and g inverse of 3. Okay. So for g of 3, we know that when x is equal to 3, g of 3 is just equal to 1. Okay, so we got that part. That part is pretty straightforward. Okay. Now for g inverse, it's a little trickier. So we have, you want to remember that g inverse of 3 will equal x. Because remember, you now have your y value. That comes from g of x equals y. If you apply g inverse to both sides, remember the g and the g inverse will cancel out if it's 1 to 1. So g inverse of y would equal x. Okay. So this basically asks us what y value of 3 will give us x. Yep, that would be 5. What value y equals 3 corresponds to x? Okay. So here, now if you wanted to actually work it all out, you could. Because you could have g inverse of 3 equals, I guess you could say, well, g of x equals 3. So g of x equals 3. Apply g inverse to both sides. So you have g inverse of g of x equals g inverse of 3. Remember, those two cancel out because you can see it's 1 to 1. So you know that g inverse of 3 equals x when x equals 5. Because now you're just looking at when y equals 3, x is equal to 5. Because before, we had when x is equal to 3, y is equal to 1. When y is equal to 3, x is equal to 5. So here, your y is equal to 3, so your x is equal to 5. So it just flips everything over. Does that make sense? All right. Okay. So this is your g inverse of 3. All right, and these will be in your scanned notes. So here you want to find the composite function of f of g of 2. Now this is just like if we were doing it with the function itself. Well, the first thing you want to do is find g of 2. Okay, so this is our g function. G of 2 is equal to negative 3. So g of 2 equals negative 3. So really all we have to find is f of g of 2, which is just f of negative 3. So now we look at our f function and find f of negative 3, which is 4. So we know that f of g